All right, we are now nearing the end of this whole course, and you may have noticed that we kind of we're into one phase, and there's only one chapter, and that is basically the implementation phase. And so we went from the system planning through the systems analysis through systems design, and now we're in the idea of actually implementation, which is what most of your courses in college really is about. So there's a little bit of conversation here coming up about what's important, like, what the industry standards are. But then at the end of the day, what we see happening is a lot of our design, we still got a little bit of charting to do, but most of it really now goes into sort of the coding and then unit testing, and then ultimately trying to train and document how our system actually works, then cutting it over, and then finally, what do we tell management when we're in theory finished? So it's obvious, right, that companies are quite concerned about the quality of their stuff. I mean, when stuff fails, especially customer facing, it can actually have legal ramifications. So for sure, people are concerned. So the objective really is, as soon as you find any kind of problem, and this is again for quality assurance. Quality assurance should have actually been involved throughout the whole thing. And it's, I think, a fault of the book that they bring it up only now, because in theory, you can have quality assurance involved during the requirements gathering, during the design, and now certainly when you're actually building the stuff. And their goal should be to find problems as quickly as possible and help sort of improve the quality. Now, software quality assurance is actually a discipline inside of software engineering. And I know I took a course, part of my master's was actually a whole course in this. So a whole course in it. You'll get a couple slides. It was like a whole course. But the deal is that the industry, through things like the capability maturity model, which I'd ask you to sort of definitely look at, I think there's a slide coming up, are basically meant to help improve the quality of the software. And so what you'll see is actually the CMMI, which is part, by the way, of this capability maturity model. So it's just the I for index, or integration, excuse me, integration. The deal is, what they'll do is they'll go into a shop and see what level of proficiency of quality is the shop. So if they want, let's say that you worked at Blue Cross and they want to do an evaluation of your particular piece of Blue Cross. If basically it's just uncontrolled chaos, which is kind of what most of them are, then you're level 1. If you can basically accomplish a couple of goals and they can be demonstrated, then, and they come back and they measure you, you can be a CMMI level 2. And this actually matters in the industry. Like, I'll tell you, and the book kind of outlines what each phase is, but each step is. I think probably when I was really paying attention to this, there was only 3 shops on the earth that were actually at level 5. That could basically prove they're at level 5. And you kind of see some of the stuff when you're driving around and you look at factories and they boast out in front what ISO level there are. It's the same kind of thing, except it's for some way of ensuring quality in your software. An interesting sort of anecdotal story is that in the beginning, when furnaces were kind of being automated or whatever, a furnace basically blew up and basically killed a whole bunch of children in a school. And so that prompted the people that maintained furnaces to have a license. And now it's software that controls the furnace. So software certainly does matter. And you can bet, like NASA, for example, is not sitting at level 1. I don't know what level they are, but they're not sitting at level 1. But sometimes some shops can't afford this. Every level costs money to actually achieve this level of proficiency. So anyway, that's just something to bring up. It's all part of sort of the international organization for standardization. And again, I'll just let you look more at that. So now when it comes to just simply application development, regardless of what level you're at, it's basically the process of building the project now. So in theory, we are now building the Dignity Center client tracking application, or we're building D2L now. We'd probably even give it a name. And we got a couple of options. We can do it the structured way, which a lot of companies still do, the OO way, or agile. And I will tell you that, quite honestly, a lot of companies do a combination of all three. So the first thing we do is we look over our design, the outputs from the previous step. Remember, in the waterfall model, the outputs of that step become the inputs of the next step. So, so in this case, we see a return of the functional decomposition diagram. And boy, we're actually going to see another kind of an interesting version of an FDD in a few minutes. We'll look at the data flows. We'll look at any object-oriented models. We will decide what is the development strategy. Are we going to build this ourselves? Are we going to buy it? Are we going to use something as a service? We're going to design the user interface, which is a couple chapters ago. We're going to look at any of the data structures and how they're actually working, like basically the databases. And then the last chapter 10 would have been basically about the overall architecture, how the networks and stuff are going to work. And so at that point, now we're ready to start building. And now here is sort of a traditional method. We kind of plan, design, code, test, document. That's all part of the development. So we build maybe, either we build D2L in its entirety, or we build a piece of D2L. We do some integration testing. So by the way, when we're talking testing here, we're talking unit testing. We're testing the code modules. Then we see how does it work together as one unit, then how does it work within the existing system, and then we document. And I would argue that even this is not necessarily quite accurate. You're probably going to be documenting as you go as well, right? Agile is a little bit more agile. It's a little bit, you can kind of get a sense here. This is pretty linear. This is pretty iterative, and that's kind of the deal here. You got your concept, you start to plan for your release, you do your iteration. Is there a new kind of requirement that comes out? And you kind of do this for a bit, and then finally you start, you basically, you build, you got your tests, go to the next iteration for a bit, and then when you're ready, do a release. So you can kind of see like circles, right? But this release, D2L is going to be able to handle discussions. We do the discussion, looks good. Let's do some testing, maybe build another feature, and then release. So entity relationship diagrams, we know those are for flowcharts. We have not done yet. We're about to see, yes, we did. Sorry, we did flowcharts earlier. We were talking about processes. So that was the triangles and all sorts of stuff. Sorry, not triangles, diamonds. Anyway, we did flowcharts, pseudocode, decision tables, decision trees. Here's an example right now of using some pseudocode. So we get all this stuff together. Here's our decision tree that you might remember. Here's, and this all basically goes into starting to create another type of diagram for us, a structure chart. Now, I'm going to tell you that I don't see too many of these structure charts out in the wild, but I do see different versions of them, and I have created my own versions of these. So they're not a bad deal to understand. What I want you to sort of imagine is that you have this particular program, which is calling these submodules, all right? So this program is calling these submodules. And because it's controlling these modules, it's called the control module. These are subordinate. This would be the module 1 would be the parent of module 2. This guy here is a library module. Maybe it's got a bunch of stuff in here that other things are using too. For example, maybe it's got some sophisticated financial functions that are all basically bundled into this particular module that other things will use as well. So when one module calls another subordinate module, it is already coupled. So it's coupled. When one module calls another module, it's coupled. The question is, what kind of coupling? Now, in this case, this module is shooting data down and getting something back. And if you look at it, it makes sense, right? This particular module, lookup customer name, is probably one of a bunch of modules all about maintaining customer data. So we shoot the customer name out and out, the number, We give it the number, we get back the name. That is data coupled. In here, this module does a couple things, right? And we got to assume, by the way, it is doing it in this order. In this case, by the way, order does matter. So it's going to check the customer status, and then it's going to update the file. How does it get the customer status? Well, it shoots out the number, it gets back the status. It shoots, this thing must figure out the charges, shoots the charges in, and then look at the difference. These guys are hollow. This is something different. It's actually a flag. It's a flag, and it's going to shoot back the flag, basically saying this guy is overdue, or they're not overdue. It's a positive or negative. And what that means is that in this case, what's happening down here doesn't control what's happening up here. It basically, it's asking for a status, and it gives it a number. This thing is going to behave differently if the account is overdue or not. This flag will control how this guy runs, and that's why this guy is control coupled. This is the control coupled part. This is the data coupled part, okay? And what you're trying to get to is you're trying to get as much as possible in your design to have as minimal amount of coupling as possible, and certainly as minimal amount of control coupling as possible. We'll see some examples in a minute. A couple other symbols that you should know. Up here, it says sort inventory parts. And notice that you got these three subordinates. You got sort by part name, sort by part number, sort by inventory value. That doesn't make a lot of sense. Why would you sort by the part name, then sort by the part number, then sort by the inventory value? Well, you won't do all of those because of this symbol right there. This symbol basically means do one of these. So do this, or do this, or do this. That is a condition, and it's a diamond. Now, when you look at this guy, produce grade reports. Get the grade, get a student grade. So notice it says get student grade. And you can tell by the way, it's only shooting a student number and shooting a grade back. Then it calculates the GPA of that student. And then would it really produce one grade report for that student? No, because what's happening is that there is a little bit of iteration going on here. It's going to get the student. So it's going to pass the student number. It's going to get back the grade, shoot the grade in, bring back the GPA, get the student number, get back the grade, shoot the grade in, get the GPA, and it's going to keep doing this until our little end of file, until it gets to the end of the students. This guy is now control coupled. This will control the behavior, because what's going to happen now is as soon as it gets the end of file, this guy is no longer going to go to this, calculate GPA. It's going to go over and then shoot the GPA listing and then get back the report. So that's actually a pretty good example of control coupling as well as iteration. So if we had one module call check customer number and credit limit, you kind of get the impression this particular module is doing more than one thing. Right, it's not doing just one thing, it's doing two things, right? It's checking the number and getting the credit limit. Because of that, this module is not as cohesive as this model. Imagine the same thing calling it, but this guy's calling one thing, which is check customer number. That's the only thing it does. Check credit, customer credit limit. That's the only thing it does. These two modules are more cohesive, and this design is more cohesive. The reason this is important is that if you found out there was a problem with checking the customer number and you had to go in and fix it, this is going to be more expensive than this, because in this module it's going to be bigger and you're going to have to figure out where it is it's checking the customer number. In this module, the entire thing is checking the customer number. So it'll be way better in your design to have something that you have a bunch of little modules that each do one tiny task. And it used to be, I don't really know anymore about some of these languages, but if your code was more than a foreseeable page, it was too long. So there's something to keep in mind with that. So coupling is the degree of interdependence among modules, right? So this guy here, there's some interdependency here, and this is a data coupling. Here, there's control coupling, right? These guys, again, this module is dependent on this module is dependent on that module. So modules that are independent are loosely coupled, making them easy to maintain. Tightly coupled, not as easy to maintain. So here's a good, pretty well example of something. This already looks a little bit complicated to try and maintain, right? Basically, I know it looks like, hey, look, there's only one thing here. How hard can that be? But look at all the activity that's going on. Whereas in this guy, same functional idea, but I got to imagine, by the way, that somehow the discount was in here. I wish they should have said apply discount and calculate charges. But anyway, in this case, if I know the problem is that the discount is incorrect, I would go and look in this little tiny module, and I could probably find it relatively easily. If I knew that the problem was that, hey, the new balance coming out is wrong, well, I know to look in this module because the new balance is coming out of this module. In this case, this is too long. When I was 16, I wrote a program that was super, super long. And of course, no one ever sits down to write a program like that. It just grew and it grew and it grew and it grew and it grew. And it became a remarkably incohesive, tightly coupled mess. And after a while, it broke, and I just simply couldn't fix it. And I vowed never to do that again. And so far, I have never done that again. I always keep my modules really, really, really tight and tiny. All right, so these are all like bits of a structure chart. Now we're talking about how would you write a structure chart. So look at DFDs to make sure your DFDs are complete. Look at the subprogram, try and figure out what are the program modules, what are the subordinate relationships. What are the couples? Are there any loops? Are there any conditions? And then analyze the structure chart to make sure it's consistent. So in this case, and what I wish this did, which it doesn't do, but if you had a data flow diagram beside this, this is what we'd see. If this was a level 0 data flow diagram, so not level, not context, but level 0, we would actually see 3 bubbles. Right, we'd see the 3. I'm using Jordan, by the way, for this, but three circles, and you see fill order, create invoice, and apply payment. And you'd see those circles are probably talking to each other, right? These things almost are like data flows. And so I think one of the things to think about is you can take a data flow model, data flow diagram, and make it to a structure chart relatively easily with just a little bit of imagination. Because if you took basically the level 0 and married it to the context and just dropped any concept of entities, that's kind of what this is, right? This right there is a level 0 and a level and a context combined. And notice even the numbers, right? 0, 1, 2, 3, 1.1, 1.2, 1.3. So this is certainly not complete, by the way. They're only showing us just basically this leg of it. But what I would basically see happening is here, the order module shoots down an order number. It goes to fill order. And then I guess from here, I don't know how complete this is, to be honest, but to fill order basically requires 3 things to happen. And then when we're done, it shoots back the packing list or the rejection. And just to remind ourselves, that is data coupled, and these are controlled couples, probably because if the order is rejected, then we're probably not going to, we're going to prepare a reject notice. Notice there's an if there. So we're going to verify it, or we're going to prepare a rejected, or we're going to assemble it. Anyway, there's a lot of logic there that I don't really care if you understand. The thing is, I just want you to understand how to read that and its similarities with data flows. Okay, when it comes to object-oriented applications, what you get is you get, again, these class diagrams and these other kind of diagrams all kind of work together to sort of help you build the system. And a lot of tools will actually help you build out the code behind this. And it's really all about, when it comes to object stuff, it's all about how do these guys communicate with each other. Object-oriented stuff really does lend itself well to more cohesive, more lightly coupled programming. And then we get agile as a development process. So here it's talking about how it's highly iterative. I've already talked about that. It's meant to basically keep you flexible and low risk to produce software. So they got some examples here. They're talking here about extreme programming. I brought up Scrum sometime previous. Test-driven development. This is where you actually build a test first and then build the code that would pass the test. The concept of user stories, we've already talked about before. It's just another way of basically another word for getting some simple requirements. You don't release D2L all at once. You'd release D2L in iterations, and we do have iteration planning. So this became a pretty big deal later in my life in Oracle, where we actually had iterations. They actually named each iteration after mountains. So anyway, I'll just let you look at that. Depending on your shop, it will depend on how far along they are in Agile, or whether they're even adapting Agile. Some companies, they don't trust it, so they don't do it. Programming environments. I hope by now all of you had some experience with an IDE, an integrated development environment, and hopefully you've seen and you've worked with Visual Basic. I should say, I don't care if you work with Visual Basic, but some of these languages like Python, Java, COBOL, PL SQL, Visual Basic, right? These are sort of languages that do things, and then you have a whole sort of set for the web. And I gotta admit, some of this stuff I'm pretty unfamiliar with, right? And if you're using case tools, a lot of times it can generate Java, or I don't know about generating Python, but you can get a lot of stuff generated for you. Of course, it usually costs money for that. Then how do you test it? How do you test it once it's done? And I think, yeah, this is a good diagram for this. So imagine that you're building a complete system from scratch. So what you're going to do is you're going to basically build your program one, and then you're going to test that thing to make sure it works. And sometimes, depending on how cohesive the module is, your test is literally like you're giving it some numbers, you run your program, and it spits out numbers that you're hoping it's going to get. Sometimes you have to write scripts, and sometimes, by the way, there's programs out there that will generate like 10,000 scenarios, and you basically run your little unit test 10,000 times, and then you get reports about how successful it was and when it wasn't successful. So that's unit testing. Then once that's done, and assuming these guys are done, we want to test how are they playing together. So how does these two relate together? How do they integrate together? How do these integrate together? How do these integrate together? That's basically testing one unit with another unit. And then finally, the whole system. And you're looking, in the beginning of your life, you're going to get compilation errors, right? Which are actually the easiest ones to find, obviously, because you can't even run the program. Then when you run the program, if it blows up for some reason, well, there's your execution error. But what's harder to find are the logical errors, where the program works just fine, but the results that are coming out are wrong. And that's where at least that's where we tend to spend most of our time, is logical errors. And when you're testing data, you should definitely be testing for positives and testing for negatives. You should be deliberately giving it errors and having it basically blow up. So stub testing, this is kind of what I was getting at earlier with this. If this guy was of a highly cohesive, you probably would write a little program that would actually call it and then pass in the numbers. And that's kind of sort of what stub testing is about. All right, now we're talking about integration, and I kind of already talked a little bit about the system. What about documentation? Well, hopefully you've been documenting the whole time. Hopefully all your artifacts are safe and people understand where they are. And of course, now there's no excuse for this with things like SharePoint and Confluence. There's plenty of ways to get your stuff out there. There's almost too much. It's almost too easy to have this information out there. But you're going to want to basically have something that describes your system, describes the inputs, the outputs, the logic, maybe even the controls. You should be preparing this early in the software development lifecycle, and you should be having a log of defects. What we used to do is we used to have a list of the defects, and then we'd have a list of, was this an analysis problem? Was it a design problem? Was it an implementation problem? Was this even asked for? Because the customers could be saying, hey, we expected dog food to be on here, and you could be saying, dudes, you never asked for dog food. That was right off of the requirements. So you're going to want to basically be tracking all that kind of stuff down. So you got the system documentation, how to use it, the operation, and then users here, right? So sorry, this is probably how to use it. So operations contains information needed for processing online and printed output consistent interaction. I don't know. Anyway, I'm moving on from that. Now, a lot of this is online, should be online anyway. We're long far past printing manuals and stuff. Even your manuals will basically be PDFs online. And hopefully they're living documentation, right? Hopefully what happens is that you can have a nice living documentation, which has very much like Wikipedia. I don't know how popular it is anymore, but there used to be something out there called Twiki, which was Technical Wiki, I should say, and that was beautiful because people would edit it. You could see what the history was. You'd see what they actually did to change it, and there's a lot of wisdom that came out of the Twiki. So I just don't. I want you to understand it's not just. It shouldn't just be Word documents sitting on some shared drive somewhere. It should be fairly dynamic. Even Google Drive allows you to do things like add comments and things like that. And then once you're done, you got to basically now get management's approval. So they're going to be very interested in this, in the status. They want to have all the input of everybody involved. Did it actually come out on cost and on time? Did it actually accomplish what it was supposed to do? And then you're going to want to start thinking about different environments. So far, you've probably done everything in development. And let's come on, there it is. Most of the time, what you'll see is there'll be I don't know about this picture, but there'll be basically a test environment and a development environment. Hopefully there'll be a development, at least a development, a staging, and a production. At least those three. It's horrible when you only have a development and production, and it's really horrible when you only have production. Now, what would be ideal in my mind is that you'd have perhaps a development, a build, a stage, and a production. So what are they all? Well, development is literally development. It's just a cowboy area that you build things. Then build is you practicing your patch, trying to make sure that your patch actually is going to work. So build should be really, really close to production. It should pretty well be an image, at least in structures. Stage is where you basically, it's past build, you think it's going to be good, you're going to put it on stage, and then when the timing's right, move it to production. Because sometimes you can't just move your stuff straight to production. You got to wait for windows. So now you've moved your stuff to production, what are you going to do? Well, chances are no one knows how to use it. So you got to build up a training plan. You got to think who's going to be in the training plan. Who needs to get trained, and there's all sorts of different ways, different training for different types of folks, right? You have the people trying to maintain it, the people trying to use it, and the people that are responsible for it. And and they'll all basically need training in this new system. Ways to train: if you've bought your thing already from somebody, of course, getting a training from vendor. Oracle, of course, had a lot of training. Microsoft does. Red Hat does. People definitely have their, you can get training from wherever you bought it. Also, webinars, podcasts, tutorials. I should point out, by the way, with vendor training, sometimes you could go out to the company, but that's a lot less common now. Usually they come into your company. Maybe you got a third-party vendor, somebody who actually knows Oracle stuff, but isn't Oracle, so you kind of bring them in. And there's plenty of that going on there. It's called the gray market. Plenty of those. And here they're kind of giving some tips. So train people in groups, sure. Like, it's not a good deal to have managers, IT people, and users in the same class, I think. Let me try it again. Sometimes it is, because they actually kind of get more cohesive together, and you hope that it'll slow your training down, but it'll make them better afterwards. So that's what I'd say to that. But just be aware, especially when there's managers in IT in the room, that sometimes IT people won't speak up as much if managers are sitting there. I once actually had a chief information officer in my room, and boy, nobody was willing to ask any questions there. That was ridiculous. Where can you do? What's an effective place? It should not be hostile to training. Now, I once had to train almost basically in a closet on a chalkboard that I had to hold with one hand, because otherwise it would fall over. I know that was super cheap for them, but it was remarkably hostile for me to try and teach them there. Or, other places where there's a lot of background noise. So you're going to want to basically have a nice place to do the training. And then provide for learners by hearing, seeing, and doing. So I imagine here they're basically saying that, especially doing, in this particular course, it hasn't been as easy for me to get you guys to do as much, but in other sort of experiences, that's usually where I end up trying to focus on getting people to do stuff, as well as just listening to me and seeing me. I want them to do things. So anyway, and then of course, if someone has already been trained already, hopefully maybe they'll be in a class and they can help you. All right. So boy, this is fun. We're talking about online training. We're actually in online training. So I try to make it more realistic. That's great. Sophisticated training offers interactive sessions. So this is not very interactive, but it's also not very sophisticated. I think in some modules, what they'll get is there'll be training and little things will pop up periodically, like are you paying attention quizzes or things like that that make it a touch more interactive. You guys already have books and stuff like that. And in the perfect world, if it was software, we'd actually have simulations and stuff to be able to test our stuff on our software and actually see it working. Okay, and next topic. Both this chapter and the next one are a little bit more, or I should say, less cohesive. This one now, you've got your system. What about the data? So chances are your system, there's a previous system that already had the data, and now you got to convert the data that they had. And there's decisions that have to be made, and we at Oracle had to make these decisions. How far back are we going to pull order data, for example, when we kick over to the new system? Are we only going to pull active orders that are still going? Do we want any history? If we do want history, how far back can we go? How far back can we legally go, too, by the way? Usually in data, there's a legal requirement as to, you can only go, I don't know about legal, but within the operational world, you can only have it like 3 to 4 years or something like that. So converting the data is pretty significant, especially if you're converting the data from something that's not in the same format as when you're in. I had to work on a system where the original data was in mainframe code, which is EBCDIC, and it had to go to ASCII, and even from there, it had to go to Unicode. So data is not just data. Data typically has got to get converted as it moves through, and you got to basically work on that. And then finally, this idea of the changeover. So you got your system, your new system, and you got your old system. Let's just look at a picture. Here's your new system, your old system. How are you going to just cut yourself over? And honestly, there are, as you can see, 4 possibilities. One is that you just shut down your old system on a weekend and bring up the new system. Now, this is really cheap because you're only getting one system, but boy, is it ever a lot of work. If this is, Friday shut down, Monday turn on, and then by Wednesday you've realized what a horrible mistake, you've lost, even if you go back and bring up the old system, you've now lost two days of data. So this is very, very, very risky, but it's very, very, very cheap. And so it's very, very, very seductive for upper management. Another possibility is you run the old system and you run the new system in parallel. You run them in parallel. Now this is awesome because you really don't turn off the old system until you know the new system is good. The problem is it's really expensive. And sometimes you can't even do it, depending on how different systems work. I would actually make the argument almost that if you had a totally different system, this is not practical at all. But if it's a version, like version 1 to version 2, this might be possible. But it's expensive, right? Because you've got to maintain these 2 systems. So this isn't typically used a lot either. This is a fairly common one. You've got the old system, and you release it to perhaps a pilot group. Now, I've seen Facebook sort of do this. They basically release it to a pilot group, and when they think they're good, they all of a sudden turn off the old system and shift everyone onto the new system. So it's a pilot group. I'd say the only big risk here is if your pilot group isn't diverse enough for you to perhaps get a true, honest testing on it, right? If your pilot group is, let's say you've got a global enterprise and your pilot group's Canada, it's probably not good. I would personally make Asia Pacific the pilot group, because there's so many different business models you got to deal with there, different well, obviously even the languages with the Unicode and all that kind of stuff. That would be a much better pilot group, although that would be pretty tough though. So I don't know. Anyway, the thing I kind of like better is this phased approach, where you kind of release it to one group, see how it goes, and you release it to the second group, release it to the third group, and then finally you're on. Right? Little more expensive than the previous one, because each one of these costs. And so what you can kind of see here is that the direct cutover is super cheap but pretty risky. Parallel is a really expensive but very low risk. And in here, as I said, pilot was cheaper because you only do that cutover once. Phased is going to be more expensive for every cutover. They would argue they're both the same level of risk, and I guess I'd argue that too. And then when you're finished, you're done. You're not done, because now you want to get feedback. You want to get feedback of the quality, and you want to evaluate with the users, like how did it go, and then and get some kind of post-evaluation report, which you're going to give to management. Now, some people call this post-mortem, which means after death. Some people found that depressing. It's funny, one male said that's depressing, you should call it postpartum, to which I said, man, you don't know women. So I wouldn't be saying postpartum either, but I think and that's probably why they stuck with post-implementation. But there should be some attempt afterwards to evaluate how did it actually go. The only thing is about this that sometimes it's hard to do, because the developers aren't just sitting around writing reports. By now, almost all the stakeholders in this project have moved on to other projects. So it's difficult to get people in the same room again and find out, like, how did it go? So that's just something to bear in mind. But I would argue it's probably worth it. All right, so that's all there is to the idea of implementation.